Hello, this is Peter from Educomondo and a warm welcome to our first STEAM lesson, Teacher Edition. As you know, STEAM stands for Science, Technology, Engineering, Arts and Math. This Teacher Edition of the STEAM lessons has been made to help the very beginning STEAM teacher. No prior knowledge of programming or electronics required. We call this level the Explorer level. In our series, we focus on teaching students to work with a microcomputer, how to program the microcomputer, and how to make the outside world interact with this microcontroller through sensors. This is exactly what makes STEAM so much fun, not only for the students, but also for you, the teacher. It will be really rewarding to build and construct projects with your students, and you'll be amazed by their creativity. This STEAM course is suitable for 14-year-old students and up. Although this target age is flexible, the projects assume some basic knowledge of math. Many of the projects require the minute handling of small electronic components, making it less suitable for younger children. Although the projects in themselves are safe, you should always warn your classroom at each beginning that electronic components are not like candy and should not be eaten. Also, electronic components can get hot, especially when wrongly connected. At the beginning of our lesson, we always point out what we will cover in the class. Today we want to become familiar with the Arduino microcontroller. Secondly, become familiar with the Arduino development environment, or IDE. Third, to have the microcontroller print "Hello World" on the screen or monitor. And the fourth, to obtain data from that monitor. Let's get to know our project equipment. For our lessons, we will use the microcontroller from the Key Studio STEAM Starter Kit. We have chosen this kit from many others because it comes with these cardboard figures that make the projects more attractive for the younger students. However, you can use any other starter kit because most of them contain basically the same components. It is also quite possible that the starter kit is no longer available. From the classroom preparation instructions in Lesson 0, you have already mounted this microcontroller on a plastic plate together with a breadboard. At the heart of our lessons, we will use a microcontroller based on the open source Arduino hardware. You can start your lesson by guiding your students through the most important components of this microcontroller. Regardless of the size or brand of a microcontroller, there are a few recurring components. The first one is the main microchip, or the heart of the controller. There is the power supply, which can be used with a 9-volt battery or a power bank. There is the USB connection, which is also used as a power supply from the computer. There is a crystal, which is used to control the timing and is essential to control the different functions of the microcontroller. There are the connection pins, analog and digital, to be used as input and output of external devices and sensors. There is a reset knob to restart the program. Then there are built-in LEDs like transmission and receiving or even control LEDs. By the way, in the second lesson, we will teach how a breadboard is constructed and how we will use it. A microcontroller needs to be programmed by connecting it to the computer via a USB cable. Listen to the sound that you hear when plugging in that USB cable. It is a confirmation that the computer recognizes the microcontroller. and you can see that a couple of small lights start to blink. Ask your students to power up the computers and connect the microcontroller. Let them confirm that the microcontroller is working by looking at the LED lights. These should start blinking. The next step is to open the Arduino IDE by clicking the icon. IDE stands for Integrated Development Environment, and it is the software that we will use to program the microcontroller. If you have not yet installed this on the computers, please go to the Setting Up Your Classroom instructions from Lesson 0. The programming language that the Arduino IDE is using is Simplified C, one of the most powerful programming languages. We will use the latest version of the IDE, but older versions are very similar and can still be used. You can see that the Arduino IDE is split into two parts called the void setup and the void loop. On top of this, we will create a new space, and we start with two forward slashes. This tells the Arduino to ignore what follows. It is not part of the code, it is called a comment. Here we type /project1 hello world. From the very beginning, we will pay extra attention to good programming practices. Programming in a clear and understandable way so that someone else will be able to easily understand your program. In most courses, teachers and students simply copy-paste code. We will not do that, simply because you will not learn anything by copying code without understanding what the code actually does. We want to have the Arduino print Hello World on the screen or monitor. First, we will have to instruct the microcontroller to start the serial monitor. This has to be done only once, so we will place the command in the void setup area. For Arduino, the command to start the serial monitor is serial.begin and in between brackets 9600, and we end with a semicolon. 9600 is the baud rate, the speed of which the computer communicates with the printer. Very important is to end your line of code with a semicolon. Repeat this often to your students, as it is one of the most common mistakes made writing the Arduino code. In the next section, we type serial.print, and in between brackets and hyphenated, we write hello world. And end with a semicolon, of course. To pop up the monitor, click on this icon in the right corner, which looks like a small magnifying glass. Now we have to upload the program to the Arduino by pressing the upload arrow. The serial monitor will show a fast-moving text line. Ask your students whether this is what they had expected. This is a good moment to get more interaction in your classroom. Let the students think for a while what is going on. Let them tell in their own words what is going on and what they would like to have to see changed. So first of all, we want to have it printed one line below the other. To do that, we change the print command into serial.println. Adding the ln will break the lines. And also, we need to introduce a delay to slow down the words on the monitor. So we go back to the top of the program and we type /variables. This indicates that in this section we define all the variables that we will use later on in the program. This way of working is important for later, when we get into more complex programming. Making the program nice and tidy will ensure that it is easy to understand and to find errors. Because we want a delay, we will define a time variable. In other words, a number. int dt equals 1000. Two things in this respect. Have you seen how the color changed of int? This means that the program recognized the command. In this case, defining an integer. An integer is a type of number without any decimal places. For instance, 1, 10, 100 are all integers. The second thing is that we need to remember that in the Arduino world, time is defined in milliseconds, so 1/1000th of a second. 1000 means 1000 milliseconds or 1 second. Let the students upload the changes and check whether there are no error messages. If there are error messages, first let the students figure out for themselves. Let them try a solution and upload again, multiple times if needed. They will learn a lot from their mistakes. If there are no programming errors, the Hello World will now print line by line a second between each line. Because the code is in the void loop section, the print command will go on forever and ever. The second part of this lesson is introducing some more challenging programming by interacting with the microcontroller. Explain clearly to the students that we want the microcontroller to say "Hello World" and then "What is your name?" Wait for input and reply "Hello," adding your name, "How are you doing?" Ask the students to think what would be needed. So the Arduino is asking for a name, and since we all have a different name, this will be a new variable. Where do we put the variables? Indeed, at the top. This time it is not a number but a text, and a variable text is called a string. So we say string your name. Here you can make a deliberate error. You'll make use of this error later on to check the student's problem-solving capabilities. The correct code should be string your name ending with a semicolon. We go back to our void loop section and use the following commands. Serial.println, in between brackets and hyphens hello world, and we also make some spaces here. Serial.println, what is your name, ending with a semicolon. Ensure that your class pays attention, as it may look a bit complicated for their first program, because it's a code that they will need to learn by heart, and we will use it again in later lessons. So while, in between brackets, serial.available, double brackets, double equals sign 0, and then we open the curly brackets and close the curly brackets. So what does this code really do? Well, this code asks the program to do nothing while the monitor is waiting for input. The expected input is a name in the top line. The program will read the name, and this is done by the following command. Your name equals serial.readString, open and close the brackets, and then you can continue with the serial print hello, serial print your name, serial.println how are you, and end with a delay. Explain to the students why some of the text is between quotation marks and others not. When between quotation marks, it is text. When not, it refers to the variable that we declared earlier. And now we upload the program again, and of course there is an error. Ask your class what has gone wrong. It is important to allow for errors. It will give the students the opportunity to think about the code, to discuss amongst each other what the error means and what the solution could be. In this case, you deliberately forgot to end the line with a semicolon. Again, in your class, don't be afraid to introduce deliberate mistakes so that the students learn to think critically and develop their problem-solving skills. Correct the error and run the program again. Now it's time for your students to program the same. We are almost at the end of our first lesson. Time to repeat with your class what they have learned. The first instance is to become familiar with the Arduino microcontroller. Secondly, to become familiar with the Arduino development environment, or IDE. To have the microcontroller print "Hello World" on the screen or monitor, and to obtain data from the monitor. Don't forget to congratulate your students with their hard work. To round up your lesson, give the students some homework that goes beyond the programming and the Arduino electronics. This will help them to get a broader view on the world. Since we greeted our world with "Hello World", here are some questions about our planet. You can ask them to go to the library to research the answers. Begin your next lesson by revisiting the assignment and ask some students to come forward and present the answers. What is the circumference of the Earth? What is the diameter of the Earth? How many people live today on our Earth? What are the planets in our solar system? How far is the Earth from the Sun? Wish your students good luck with the assignment. I'm looking forward to start with lesson number 1. In that lesson we are going to introduce our first electronic component, the light emitting diode, or LED. The lesson is called The Eye of the Dino. Bye bye for now.